3D printed tools. You love them, I love them, but they are not all created equal. That's why I spent hours scrolling through thousands and thousands of the top trending and most downloaded 3D printed tools and gadgets from across the interwebs, hand-picking the absolute best ones. And then I printed out and tested over a dozen of them, all in order to figure out which ones are and which ones are not worth your filament. Let's get after it. First up, let's start with one that you won't actually find on printables and one of the few models that I actually did not print on the new FL Sun T1 Pro that you see behind me. And that is this awesome set of hardware design boards. Now, in case you missed Alexandre Chappel's recent video, do make sure to check it out after this one using the link in the description. He explains in much more detail than I can here. But basically, the idea is that you have all the various different clearances for each different type of fit, for example, push fit or slip fit and so on, and then across all the different metric hardware options. Now, I've lamented in the past on this channel about not being able to choose or know just the right clearance when designing parts. So if you do any amount of 3D modeling and designing your own parts like I do, you will immediately recognize the value in something like this. And fear not, because even if you don't have a multicolor printer, it is really easy to print these out on a standard printer with just one color, just by pausing and switching the filament. Up next, here's one that I actually generally buy for around here in the studio, and one which, as you can see, I do buy a lot of. There are these handy little plastic clamps, you probably have some, and they're a staple of content creators like me everywhere. Now, in the past, I kind of thought that fully 3D printed clamps like this either wouldn't have enough tension to hold the stuff that I use them for without a metal spring, or that they wouldn't stand the test of time. But when I saw how popular this model was becoming, I did decide to give it a chance. I first printed them out of PLA just to see if they would hold up at all, and yeah, they didn't. My 4-year-old literally pulled them off the build plate, gave them one squeeze, and then handed it back to me with an all too typical, "Dad, it's broken." But I didn't give up there. I did decide to print some more of these small ones out in Prusament PETG, and to my surprise, they actually exert a lot of force, and they've held up to a reasonable amount of abuse so far. But as you can see from the B-roll on the screen right now, I generally do buy the larger versions of these for around the studio. So I decided to see if this model would scale well. I actually carefully chose 20% infill and 3 perimeters, and then I scaled it up to 200%, and the result was absolutely awesome. It actually far exceeded my expectations. The inserts still snap in perfectly, and the clamping force is really good. I actually tried to measure it to compare it to the store-bought ones that I have, but it actually maxed out my mini scale, and I don't have another scale around here. I'm also sure that I could easily increase the strength by adding more perimeters or infill, or switching to something like ABS or a high shore hardness TPU. You could even print it out in a high temp material like PACF if you want to clamp together something while it's in the oven. Definitely don't try that with the store-bought ABS ones though. Another cool thing about making these with 3D printing is that you can make exactly the size you want with the exact clamping force you need. But the ultimate vote of confidence for this model is that I can safely say that I am now never going to order the store-bought ones again. 2 thumbs up. While we're clamping, let's talk about another type of clamp, this time screw clamps. In one of my earliest videos, I shared the popular Prusament clamp model, and I mentioned how I am literally always printing them out for different purposes or even remixing them to have wider purposes. But to be honest, they actually have a few limitations. First, they aren't all that strong for how much time they actually take to print and how much material they use. Second, the ball head on the screw always ends up breaking off at the thinnest point when you apply too much pressure. But perhaps most importantly, they only come in one size, and if you scale them, you're going to have issues with the clearances. By the way, I do really appreciate those of you who commented on my recent video and actually let me know the difference between tolerances and clearances, so thank you for that. Anyways, when I saw this next print climbing the ranks on printables, I was perhaps a little bit more excited than a person should be for a simple 3D printed clamp. But I had a few reasons. First, because the screw prints lying down instead of standing up, it doesn't have a very thin failure point or the improper orientation. so this clamp shouldn't suffer from the ball head issue. Second, it seems to use material in a little bit of a smarter way with hollow cutouts that add perimeters while cutting down materials, and which I assume would yield more strength per gram of filament. But third, and perhaps best of all, it comes in a variety of sizes. Rejoice! Now, I printed out the large one in Prusament PETG, and I've been impressed with just how well it's been holding up around the shop, so do make sure to check it out. While we're talking about heavy-duty parts that can take some abuse, check out this heavy-duty remix of the bag coat hanger you may have seen online. Yes, I know, it's not exactly a tool, but the designer actually did something clever here that I did want to highlight in this video because I do think that it will be a valuable trick to have up your own sleeve when you're designing parts. Now, you might already see if you look at the outside of the part closely that there's something a little bit funky going on with this extrusion. Well, if you look in the slicer, you will see that this part actually has internal geometry, which then forces the slicer to create a bunch more perimeters, not just on the outside, but also inside at the core, making this extremely strong. I also love the little attention to detail of actually slanting the inner surface of the hook so that this entire thing will balance nicely when you hang it up, even if there's a heavy bag on it. This is a brilliant, simple solution to a problem that many of us have, so well done. By the way, in order to print all of these parts in time to actually get this video out in a reasonable time frame, I needed a printer that was extremely fast, but could still churn out the parts at both high accuracy and high quality, which is why I chose to print most of the models that you're going to be seeing in this video on the brand new printer from this video's sponsor, FLSun, the T1 Pro. This is actually my first ever Delta printer, and all I can say is, honestly, wow. This thing moves. The only limitation I had with it in terms of speed and performance and quality was that I just didn't have enough high flow PLA to keep up with this machine, and so I did have to print a lot of these parts with regular PLA, which, as you'll probably see in some of the finer details, just can't keep up if you want to print as fast as this thing is actually capable of. So I'm going to be ordering some more high-speed PLA. It also, I'm very happy to report, introduces a new silent cooling system which keeps the noise down to only 55 decibels with the door closed. So you can actually be in the same room with this while it's actually printing, which is more than I can say for many printers that print at this speed. And of course, the T1 Pro offers all those modern conveniences like Clipper, a easy-to-use touchscreen interface, a webcam, web interface, and much, much more. Anyways, you'll be seeing much more of this printer and its high-quality prints throughout the video, but if you're looking for a reliable, professional-grade printer that can churn out ultra high-quality parts faster than, honestly, any printer that I can think of on the market right now, visit the link in the description to order the T1 Pro today. All right, let's get back to the video. Okay, now let's turn to storage because, as you guys all know by now, I love a good 3D printed storage solution. Not too long ago, I actually printed out a few of these different hexagonal bins in different sizes, and I was pretty pleased with the result. Unlike the IKEA-style bins that I had designed to be printed in vase mode, these ones actually hold up pretty well to abuse, and more importantly, they don't use as much material. Well, I'm also happy to report that clearly I wasn't the only one who liked these bins a lot, because since I originally printed out the first size, they've been remixed a ton, and folks have not only added lids, but also made inner stackable versions that can stack on top of or within the larger ones. Now, there are a bunch of different various versions and sizes of these, so do make sure to check in your slicer that you're actually printing compatibly sized ones. But yeah, these are great, and as you can see, they also make for a really, really good last meter print if you want to use up a bunch of nearly finished rolls of filament. Actually, on that note, I've kind of been toying with the idea of sharing my favorite last meter prints to help finish off all those nearly empty spools of filament on your shelves, but I'm actually not sure if anyone else has that problem like I do, so do let me know in the comments below if that would be a video that you'd actually watch. While we're talking about organization, which honestly I could talk about all day, let's talk about this brilliant concept for a sorting tray. In the past, I had printed out this other one, and I thought that I was pretty fancy for being able to sort two different types of hardware at once. But if you, like me, tend to throw things in a catch-all bin of horrors and say that you'll organize it later, you know that 2 types is not nearly enough. That's why this tray is available in all different variants, all the way up to 8 different slots with detachable little side bins for then relocating the parts once they're sorted, or pouring them into your Gridfinity funnel. You also could just print out plenty of extra little side bins so that you can swap them out once you've sorted all the hardware of a certain type out of the sorter, which is cool. These work great, and I will definitely be using this if and when I ever get around to sorting my miscellaneous hardware bin. Never gonna happen. But there are 2 things that I would have done differently. So designers, if you're out there, do give these 2 things some thought and maybe upload a remix. First, in order for the height of the sorting tray to be enough that the bins sit below it and gravity does its thing, you do end up printing a big empty platform, which also takes up space on your shelves when you store it. I at least mitigated the filament waste part of it by printing it with lightning infill. You can kind of see the top surface didn't turn out perfect as a result, but it would have been really cool to have some kind of trap door in the sides of the bins or something that is lifted up when they're docked so that everything could still sit flush on the table and you could slide hardware into the bins from midway up the bin. It's just an idea. Second, it does feel like a missed opportunity to not just make these into Gridfinity bins. Now, I understand that the way that the pins stick out, they would never actually work in your drawer as Gridfinity bins, but if instead you made the bin into the female and the sorting tray as the male, then you could actually do away with the need for pouring them into another bin to put them in your Gridfinity setup, and you could probably adapt any Gridfinity bin of any variant except maybe the Gridfinity lights to actually accept the male pins, even if maybe they protruded a little bit into the bin while you were sorting. Sorry, a little bit of a rant there, but again, just an idea. Anytime I see a model with a name like the greatest or the ultimate, my ears kind of prick up, like the audacity, right? But I decided to print this one out and test it out, and yeah, it's pretty damn awesome. I like how it comes in many different varieties depending on how many towels you actually need to hang. And I like how, unlike the normal towel hook that we've all seen before, I like how there's a ton of added surface area to just glue it or double-sided tape it to the wall instead of needing to put holes. I don't know if it's the absolute strongest towel holder on the planet because of the way that the layers stack, especially if you printed it in PLA, but you could just print it in PETG or even TPU for better layer adhesion. And it certainly is much more convenient and aesthetically pleasing to hang your towels like this as opposed to trying to find the little loop each time, and the towel won't fall off. Also, it uses almost no filament. So I guess I begrudgingly concede that this may, in fact, be the greatest towel hook of all time. Up next, check out this scoop. It prints like this with no supports, and because of this unique curvature, it offers this very unique ergonomic wrist pivot scooping function, which for some reason was very natural to every single guy that I handed it to. Also, this design is much stronger than your average flimsy, cantilevered handled scoop if you're scooping up heavy stuff like sopping wet filament shreds or mud. So nicely done. Okay, this is genius, and I don't know why none of us ever thought of this before. You know when you're cleaning up your kitchen after cooking, or if you're cleaning up your workbench after deburring and removing support material and stuff, and you do this kind of awkward, like, twist of the hand motion to try and get your hand to make a cup, and then you inevitably drop some crumbs or whatever you're sweeping onto the ground, and now you have to sweep the floor as well? Well, check out this bad boy. Wow. How cool is that? It's a super quick print, and the only complaint I actually have about it is that these sharp corners right here are right next to where you're supposed to be sweeping stuff into, probably with your hands. So if you're going to print this, do us all a favor and just chamfer or round off those corners and upload a remix. But otherwise, oh my gosh, what a totally awesome idea. I am totally printing out another one of these for my kitchen as well. Now, all I need to go with it is some kind of brush that does a better job than my hands at actually sweeping things like dust into the bin. Well, good news, because thanks to Devin at Make Anything, you can now actually print that too. These brushes are cool for a lot of reasons. First, the way that he uses bridging to create the bristles. Second, the detachable and customizable brush parts, so you can have the density that you want with the material that you want for the exact brush resistance that you want. But moreover, this means that you can just replace the bristles instead of needing to replace the entire brush and throw out the old one like you probably do with the wooden ones that you buy at the store. So paradoxically, this might just mean that this 3D printed plastic brush is kind of a more environmental choice than buying and tossing out the store-bought ones that you're used to. Now, this small version is free, but if you support Devin on things, there are a bunch of different sizes, and he even has paired dustpans to go with them, which I thought was pretty cool. Now, let's switch over to soldering and talk about helping hands. When I solder, I almost always do that kind of awkward thing where I try to balance the wires onto the soldering iron and then juggle the iron and the solder in such a way as to not burn myself. It's not great. So I have been meaning to print one of the many different 3D printed helping hand solutions out there. And after looking through probably 100 or more of them, I decided that 2 arms was enough for my uses, and I chose this model. And I'm actually not sure that it was the right one. Because of the minimal contact area for the socket cups, paired with the fact that you have to do a lot of bridging on the top of them, I actually had a plate full of these fail 3 different times on 2 different printers. Now, I finally did get it to work with a full plate brim, a very slow profile on a printer that is designed for PETG, and a whole lot of Magigoo. But still, removing all the brims inside and outside because the slicer has no way of differentiating was a huge pain in the butt, and I kind of just lost patience, to be honest. So unless you genuinely need the ability to precisely position the arms for, say, soldering PCBs, I don't. I would say just skip all these complicated models with all these tiny little cut balls that are really hard to print, and instead print out this simple one that will work just as well for soldering wires. You're welcome. Speaking of things that theoretically should, if they work, help out your hands, have you ever been out and about and you need to fix something, but it kind of requires pliers? Now, personally, I carry a pocket multi-tool with me everywhere, but my model of choice doesn't have pliers. So what to do? Well, check out this awesome model. It's actually a credit card-sized pair of pliers and a metric measuring tool, which should be able to be printed in place. Now, I initially tried it in PLA, and that didn't work very well at all, so I decided to print it out really slowly on another machine with perfectly dialed PETG profiles, and while that got it closer, I still broke it. To be fair to the designer, he does say that you can manually import the parts into your slicer and then position them manually to get them just right, and you could also, of course, use XY hole compensation to tweak out and expand the clearances, but I'm gonna be real honest with you guys. Both my kids have been either homesick or on holidays for most of the last 3 weeks. One of them is literally sleeping over there next to me. So, yeah.
Ain't nobody got time for that.
It doesn't take much filament, of course, but I'd probably just skip out on this model unless you're willing to spend a fair amount of time dialing in parameters and lowering extrusion multipliers to get it just right. It's a super cool idea though, so maybe you'll have luck. Okay, before I let you guys go, one more really cool one. Now, I've often seen a lot of these print-in-place bearings, and I always thought to myself, no freaking way that these actually work, right? But over the years, both printers and slicers and slicing algorithms have gotten much better. Plus, recently, I've been using a ton of 608 bearings on projects that honestly don't need to be all that smooth. They just need to turn without having too much friction. I think I used like 50 bearings on this wall behind me. And while 608 bearings are cheap, I really don't like wasting them on something as silly as just a spool roller, and then needing to order more and wait for them. It's a hassle. So as I was testing out the T1 Pro, by the way, do let me know if you actually want to see a full review video of it by commenting below. I decided to see if it could actually reproduce tight-fitting tolerances even with its incredible speed. And to my genuine surprise, honestly, I didn't think this was going to happen. It could. Though they're, of course, not nearly as smooth as steel metal ball bearings, these bearings spin quite nicely. and with a little spritz of silicone grease, they spin really, really well. But I still wanted to put them to the test in a real-world application, so I put them into some Tush++ spool rollers that you might be familiar with. And to my surprise, 3 out of the 4 of them worked just fine. As for the 4th, the age-old problem of 3D printers creating shrinkage in the holes and changing the dimensions reared its ugly head, and I did end up breaking one of the bearings while I was kind of hammering it in. But then, when I printed them off again with a tiny bit of XY hole compensation, the center bore snapped in perfectly with the absolute perfect amount of friction, and it spun so well that I actually didn't even need to lube them up. In fact, these new versions are going to work so well for really not demanding areas where I just need it to spin with reasonable amount of low friction. I actually think that I will be using these in the future instead of ordering actual metal bearings. Again, not for every project, but for things as simple as a spool roller, definitely. In fact, these work so well, I actually might just go ahead and harvest some of the 608 bearings out of other low demand projects and replace them with these. All right, that's all for this week, but I'll see all of you on the next layer.